Hi everyone, my name is Mario, and today I'm going to do a introduction about CORE-V-VERIF. First of all, how many of you have heard about CORE-V-VERIF or are working with it? Hands on? Okay, not much people. That's amazing, I would say. Okay, so what is CORE-V-VERIF? So the aim of this presentation, and I'm lucky because many of you don't know what this is, to do a little bit of an overview of our environment. So you have clear what we have, how you should use it, and how you can just get that and do your own verification stuff. Because verification is always a mess, and having open source projects like this, I think it contributes to all the ecosystem. Because verification guys normally don't know what is being done in industry. So we will see. Okay, so first, where we have this repo. This repo is inside our organization on GitHub, and it has all the test benches for all our cores. But we have many cores to verify, which if so many of you are verifiers, it's a mess. Because we have flavors of some cores, we have some new cores as CVE2 or CVA6. Mainly CORE-V-VERIF, it's our UVM test bench for all the cores. And there on a monolithic repo, we have all the benches for everything. So it has to be said that it is written in system Verilog, and it's using UVM. That's why we are supporting all the other vendors, but also we have the possibility to use also Verilator if someone is interested. It's not heavily supported because with Verilator we think that we can achieve TLR5 as David has explained, but we can use it without UVM and so on. So what CORE-V-VERIF provides? CORE-V-VERIF provides many things. First, it's a framework. So you have there all the infrastructure required to compile. If many of you have worked with many other vendors, you will know that vendors are quite messy. And if you want to change from one to another, it will require some time to adapt everything that you have. We have an infrastructure of makefiles that eases this. With passing just one argument, you can change from one vendor to another. Probably you will have to add some stuff to your makefiles in order to suppress some errors if QuestaSim just complains about some weird stuff. But it will ease you all the effort. And also there, we have many shared components that are being used in many of the test benches. So if anyone wants to do a new test bench, they can grab our agents there and do their own mix to have the bench for their core. I will be a little bit more in depth later. But right now we support these cores. It's mainly all of our cores except CVE2 because we are in work in progress. We are on the phase stages of the core, but we have planned to also support it. Okay, so this is how more or less a Verilator or basic test bench works. So it works everything on system Verilog, so it's everything signal level. It is a two-step process as you have to execute everything on your core and then everything on Spike or whatever model you have. First, you compile your C program or assembler. We hope it's C, because if not, it will be a mess. And you have to get the toolchain to compile and everything. Many of you will be, familiar with this. It's quite a standard. So you compile this and you put on both of the things. You get a trace, you compare. That's it. You're good to go. And that's fine. But if we want to achieve TLR5, we think that we have to improve this, at least using some standard techniques on the industry, which for sure are not this. Probably, as David has said, if you want to arrive to TLR4, it's enough. It's completely fine. Many of the papers or research projects have enough with this. With this, you can put many things. You can have test passing, but we believe that other vendors give you an extra and something that is required if you want to industrialize your IP. Okay, so that's why it looks our UVM test bench. If you're working with UVM, again, probably this is super familiar. It's a kind of a standard core UVM bench where I mean, it is the bench, but it also is our infrastructure. So the bench will be the UVM box, but we also have some stuff in order to align everything. Because in RISC-V and in the toolchains, you can pass many architectures. And probably, I mean, it happened to everyone that you compile something with a toolchain, you mess up the arc, and then when you load the core just doesn't work. I mean, you get an endless simulation or wherever. So CORE-V-VERIF tries to ease that, to make our life easier. Because even if you have done UVM, it's tricky. I mean, it's a good thing, but it could be better. So at least getting rid of the alignments on everything, it's better for us to just focus on what is important, on code explorations or wherever. So we have here inside our UVM box, we have memory agents, which could be many agents. I mean, many types. We have AXI, we have OVI too. We have many agents. So if you use the same thing as we do, you can just grab the agent and you're good to go. And we also have agents to control debug events, interrupt events. Right now, we support Imperas as our main reference model. But I will say something. We are on good steps to support many others. Well, many others. Spike probably, but yeah, we're at least we're in the steps to support that. Which, I mean, the industry, I think it's advancing to make everything a little bit easier for the businesses to run. Because, for example, right now, I mean, Berlator it's trying to get UVM stuff, and if you get Spike, you also have it there. So we're using also RBBE to trace the core. So with that, this interface, it's a standard interface. I think it's ours, and you can get all the state of the core from that. We expect that many people use it to standardize the way the core's output thinks. So if we have many reference models that support that, it will be easier for us to just change, plug and play, and you're good to go. And then we do the step and compare of the trace online and without being in postmortem. Right now we have this inside Imperas DB, which is the one that is integrated with the bench. But we are planning, as I've said, we are planning to also support other reference models as a Spike. So many efforts will be driven to also have on Scorevert a way to compare everything without Imperas. Also has to be said that many of our agents have coverage, functional coverage. So it's also a good stuff. If you're using AXI, you want coverage, you'll have to implement it. It's over there. And right now we have an ISA functional coverage, which is ISACOP, which is inside our repo. So if you want to not again write another ISA coverage, you can just grab the thing and you're ready to go. Now the compare. I mean, I know that everyone from here or lots of people we know, but one of the UVM good things is that you can work at transaction level, not at signal level. I think what we aim at OpenHW, at least, is to unify the test benches. I've been doing verification for, I would say, not that much time, but I'm already tired of doing yet again another test bench for one core. So probably a way to standardize and to open source the way that we are doing our test benches will be enough for us that other verification engineer can get our test bench, run with it, and then focus to the important stuff, memory subsystem test bench, or whatever. So, yeah. As I said, in the normal test bench, you have to align all the tools. But with our thing, you can just rely on our infrastructure and then have everything in the same page. Everything is used in the same architecture. Everything is nice to go. And we have also the infrastructure prepared to also support debug and interrupt events, which is a good thing. Now we are going to the best thing. I mean, I'm not trying to sell anything to anyone. The good thing of our core is open source. So you can just clone in your machine our bench and you're good to go. You don't have to tell anything to us. I mean, in the same way that you can just clone the core and do whatever, you can just go to the fab and have it physically and you don't have to say anything to us. So you can grab, as I've said, you can grab the bench, use it, and that's it. It is maintained and active development because we have many projects ongoing with this UVM test bench. So as we have seen earlier, we have more than 5 projects using it. We have many contributors, many pull requests each week. So with this, we will ensure that anything's broken. And if anything's broken, you can just submit an issue and we will attend it. So as I've said earlier, it is transparent from all other vendors. So you can change from Excellium, VCS, or QuestaSim with ease. I mean, everyone has fight with that in some time, but it's easier if we shared everyone the same thing and we maintain the same infrastructure that enables us to change between simulators with more easier than having our own scripts and so on. Also, as I've said, we have already implemented agents. We don't like to implement again and again the same things. You can just grab our stuff and do whatever you want. You can clone it, you can do another test bench, whatever, it's fine. I mean, we are fine with all the users of our test bench. And if more people uses our test bench, or at least some parts of it, it will be easier for us to find errors. Because, I mean, UVM, verification engineers are not free from errors. And mainly, I mean, if we collaborate everyone to know that our agent is healthy enough to be used, it will be better than not making an agent. Probably it will be, it will work with for the base case, and then you will have something that will break everything. So having a shared collaboration, I think it's the way to go, and in order to standardize at least the way how people do core test benches. Now I've explained everything about many things about CORE-V-VERIF, but how I can use it? Well, it's pretty simple in reality, because in order to do the tracing, you have to implement one interface on the core. It's kind of easy to get the commit ports and then output something. And with that, you will have everything on your environment ready to work. That has to be said that, I mean, you will also have to implement the memory thing, because normally we are using different stuff for memory. We probably will be using AXI, but you will be using another version of AXI. In that case, you can modify our agent and do another agent that can be pushed or not to a repo, or you can use our thing. In almost all of the cases, you will need another version of it. But if you're lucky enough and someone is already using an agent that is aligned with your requirements, you will be able to clone and get the agent and ready to go. We also have coverage and the functionality for all the agents. So also no need to do yet again another coverage of AXI. And as I've said, we have the ISA coverage, which is again the good thing. It has to be said that if you want to do it, as I've said, we have the agents, we have many things, but I like to say it like it's like making some salad, because I mean, you have all the ingredients, but you have to mix them all and do everything to make it aligned or to make it functional. So we have memory agents. If you are lucky, you can get those. If you want ASA coverage, you get those, but you have to do the test bench. In my opinion, and with UVM, I think it's possible. It will be nice to have a UVM infrastructure that supports all the cores, using a little bit of polymorphism. That is my idea, but I think it will be an objective for 1 year or whatever. But using polymorphism and transaction level, we can abstract all the memory agents, and then you can just plug in your agent, and you will not need to do yet another test bench of everything. So that in the left side is what we have now. Talking about dreams, I think it's Mike's dream for a long time to do an environment which uses UVM at this highness. We can probably, I mean, if we are using binaries, it's probably not an option, but a lot of people are using binary generators as RISC-V that are also written in System Verilog. It will be amazing to integrate everything into one place. It's difficult because producing binaries with sense, it's not easy, but it would be amazing to just get rid of many things and just integrate everything into the same environment. As I've said, we are working right now to push a little bit the reference model implementations that we have in order to be, I would say, more neutral, more compatible with many options. So that this is a work in progress, but I think in couple of months we will have an environment which is independent of the reference model, and we could just run with a spike and see if everything's well, if everything's okay, without having to depend into imperas or whatever. Also, we would like to standardize a little bit the environment in order to make it easier for the people to come in and say and fix and propose new stuff and do stuff with our repo. As I've said, right now we are depending on imperas, and everything of the comparison is done inside imperas. We are also in the good direction to have our own scoreboard. I mean, it's not hard to do a scoreboard for RISC-V, but we did not have the time to do it. So in some couple of months, I think it will be possible to shift from vendor-dependent implementation to a neutral implementation, which again, it will be easier because if you're not using imperas right now, our environment, it's not other thing that a test bench without UVM that runs. I think shifting our view to another reference model will increase the popularity of our repo, as many other people could use our thing without having to depend in Paris or wherever. Okay, so right now, this is more a little bit of why to verify, why to TLR5. But I think it's useful to, at least, I mean, many people like design. Design, it's amazing. I mean, even for me, it's attractive to do design. But for sure, we have to verify it because, I mean, even for me, it's a pain to verify something. It's a tedious process where you are almost never done, but we have to do it. And right now, I'm going to explain a little bit about the risky project, because we adopted risky, and we have forked it for on-off, and it is on our repos. So we have rebranded the risky project as CV32E40P, and we did verify it because it was academic. So we wanted to push this to another level. So we restructure everything and do parameterization. And this is what we found. I mean, it's not that, I mean, numbers are almost all the time nonsense because it doesn't matter that much. But we have found many things there. We have found 47 bugs, which probably they have to, I mean, they're related to our modifications to the parameterization. But I'm really sure that many bugs were already there. As I've said, TLR4, it's fine for most of the cases. Most of the research projects are good to go with that. But verification, I mean, it's a mandatory if you want to do many, I mean, industrial stuff. And many of our members want to do industrial stuff. So all of our cores had to be ready in that case. Here we have a graph of a chart, sorry, about the bugs that we know. We have, for example, used formal to just verify it, and I think this will be a path also to use it in another course, using vendors or using open source tools in order to also verify it. It will help us. We are also on the steps to integrate many formal stuff in our bench because I think it releases at least the first part of verification, which is normally the one that we can skip everyone and just go for the interesting part. Okay, so that would be more or less everything about CORE-V-VERIF. We have a very, very long README that many people put effort and many reviews. So you can check it out. It has all of the steps to run a simple simulation in one of our cores. It is very, complete. There you will find all the variables that we're using in order to compile. I mean, as I've said, in order to align all the tools to do the same binary, the same architecture for everything, we have to depend in many environment variables, which normally is kind of a pain, but they are documented there, so you can check it out and see the documentation of our infrastructure. As I've said, the quick start guide, it's the way you can just enter and see how you can start using our stuff. I will encourage you to, not using it, but at least take a look, because if you can use something there, it would be amazing. Just clone it and use an agent. It's fine. I mean, if more people use it, all of us will benefit. And that's it. Will be my presentation on CORE-V.